So for part A, we just want to find the value of k for which the slope of the tangent line at 0 is 6. So that part should be pretty straightforward. I think you just need to find the derivative. So what's the derivative of 1 over x squared minus 2x plus k? That should be the reciprocal rule or quotient rule if you choose to do it that way. So that would be the opposite of the derivative of x squared minus 2x plus k. So the opposite of 2x minus 2 over x squared minus 2x plus k squared. So that's your derivative. We want the derivative evaluated at x equals 0 to equal 6. So plug in your 0, the negative. Negative 2 is going to become a positive 2. And you're going to end up with 2 over k squared equals 6. Or what is that? K squared equals 1/3. Or k equals the square root of 1/3 or 1 over root 3. Could be negative also, but they say for k greater than 0, so you just want the one where it's positive. Everybody good with that one? That part was pretty easy, I think. They gave you 3 points for that. They gave you 1, I don't know why they did this. They gave you 1 point for having the right denominator. They gave you 1 point for having the full derivative correct. And they gave you 1 point for the answer. I don't know why they broke it up like that, but that's how they broke it up. So, everybody good with part A? I hope. Yeah. Okay. Part B was also worth 3 points. So for part B, they're saying for k equals -8, find the integral from 0 to 1. So we are looking for the integral from 0 to 1 of 1 over x squared, what is it, minus 2x minus 8 dx, right? Yeah. And how are we going to go about doing this? That is the right function, right? X squared minus 2x minus 8, yeah. So what are we going to do with this? In order to integrate this, we'll have to do a partial fraction decomposition. What is this factor to? X minus 4 and x plus 2. Everybody agree with that? Yeah. So then we'll do a over x minus 4 plus b over x minus 2 equals 1 over x minus 4 times x plus 2. Everybody good there? Ax plus 2a plus bx minus 4b equals 1. And a plus b x's is 0 x's. And 2a minus 4b is 1. And so we'll probably just make this a 2a plus 2b still equals 0. And subtract, so negative 6b equals 1. So b is negative 1/6. And a then is positive 1/6. Everybody good with that? Yeah? So then we'll integrate from 0 to 1. We can pull the 1/6 out. No reason to leave the 1/6 in, right? Since they're both going to have a 1/6. And it should be a, which was what? 1 over x minus 4. And then minus 1 over x plus 2. If you leave the 1/6 in, that's fine too. Doesn't really matter, but I see no reason to keep it. Then we integrate. 1/6 natural log absolute value x minus 4 minus natural log absolute value x plus 2 from 0 to 1 gives us 1/6 of the natural log of 3 minus the natural log of 3 minus the natural log of 4 minus the natural log of 2. Everybody agree with that? So natural log of 3 minus natural log of 3, those cancel. And then we have natural log of 4 minus natural log of 2. Well, that's just the natural log of 2. And so we end up with negative 1/6 natural log of 2. And their breakdown there for this was 1 point if you successfully did your partial fraction decomposition, 1 point for the integral, 1 point for the answer. Everybody good with that? Any issues there? People at home in Zoom, you good with that?
Yep.
All right. Now we got k equals 1. We want to find the integral from 0 to 2. Okay. So we're now looking at the integral from 0 to 2 of 1 over x squared minus 2x plus 1, right? So that's what it was? Positive, yeah. So we'll note what about this integral? When we factor the denominator, we end up with x minus 1 squared, yeah? Which tells us that there's a vertical asymptote at x equals 1, which tells us that this is an improper integral that needs to be split into two different integrals. So one of these will be the limit as a approaches 1 from the left of the integral from 0 to a of 1 over x minus 1 squared. And the other one ought to be the limit as b approaches 1 from the right of the integral from b to 2 of the same thing. Everybody good with that? Everyone's good? Okay. All right, then we integrate. So 1 over x minus 1 squared, that's like u equals x minus 1, right? D is just dx, so that's just like u to the negative 2. So that will become the limit as a approaches 1 from the left. So that should integrate to become negative 1 over x minus 1 from 0 to a, plus the limit as b approaches 1 from the right of the same thing from b to 2. Any issues there? Okay. So we've now got the limit as a approaches 1 from the left of negative 1 over a minus 1 minus negative 1 over negative 1 plus the limit as b approaches 1 from the right of negative 1 over 1 minus negative 1 over b minus 1. And as a approaches 1 from the left, what do we end up with here in the negative 1 over a minus 1? This piece right here, as we approach a, as a approaches 1 from the left, like 0.999, this becomes a very, very small negative. And we have a negative 1 divided by a very, very small negative, which becomes, no, it should become positive infinity. The negative and a negative. But this becomes infinity, which immediately tells us we can stop working. We have no more work to do, that this integral diverges. Everybody good there? Hopefully. And that was 3 points. 1 point for setting it up as an improper integral. 1 point for the correct antiderivatives, and 1 point for an answer with the reason. If it results in an infinity, if it results in an infinity minus infinity, like just an infinity minus infinity, Kevin, then you can try to combine things together and see what happens. Did this one happen to do that with the other piece over here? Infinity, and then this piece was, this piece is still positive infinity, so that one's infinity plus infinity. Yeah. If it becomes an infinity minus infinity, then you can combine them together and see if it, you see if you can simplify that limit in a different way. If you can't, then it's still going to diverge, but chances are they're not going to give you something that is going to result in an infinity minus infinity, at least in this regard. Well, it may, so the integral from negative 1 to 1 of 1 over x does diverge, but if you try to, so if you go through and do that integral, let's see, you end up with, what do you end up with? You end up with natural log of, are you sure it's infinity? Are you sure it's infinity minus infinity? Yeah, I guess that makes sense. Yeah. So if you take that integral that you end up with, which is natural log, so we can go through and do it real quick if you want. So it's -1 to 1. I'm not going to write out all of the I'm not going to write out all the limit stuff right off the bat. I mean, this is going to become natural log absolute value of x. This one's going to be the limit as a approaches, well, so yeah, this is going to be the limit as a approaches 0 from the left of natural log of x from -1 to a plus the limit as a approaches 0 from the right of the natural log of absolute value of x from 0, or not from 0, but from a to 1. Yeah, so as soon as we go in here and find that this piece is an infinity and this piece is also infinity, that's going, whether it's positive infinity or negative infinity, we still say that it diverges, even if it's an odd function. And you should be able, if you don't have these limits, if you just have a single piece of it and you end up with an infinity minus infinity, you should be able to separate it out into a different limit and get a value. But in this case, just showing that this is infinity. And is this one the one that's infinity? It should go for 0. Actually, this one, yeah. So this is negative infinity, and this one, as we approach 0 from the right natural log, yeah, you end up with negative infinity minus an infinity here, actually. Because as you approach 0 from the right here, if you do natural log of 1, oh no, that is a positive infinity, you're right. Yeah, so because these limits have different, and technically this should be a B and a B here, you can't combine these together. So I guess I'm gonna go back on what I originally said, Kevin, is that if you get this infinity minus an infinity here, but the limits are approaching different values, or it's A approaching 0, B approaching 0 from the right, so there's no way to combine those limits together. And so just one piece of it being infinite is enough to tell you that that integral diverges. One could try to argue that it's 0 because the amount of infinity on both sides is the same. One's positive and the other's negative. But any time that it's got any sort of piece that's negative or positive infinity in it, that cannot be combined together to get a different value using rules for logs or something like that, we're going to say that it diverges.
Couldn't you make a limit where like it is like you can make a limit that captures this and it's only one limit, and then it would approach, and then as let me try to think of one. So like maybe the limit as b approaches 0 of the natural log of x from -1 to negative b plus the natural log of x from b to 1. Yeah, so the natural log of the absolute value of x from -1 to b plus the natural log of x. Sorry, -1 to negative b, sorry. Plus the natural log of x.
New limit here, or just?
No, all within the same limit.
Oh, okay.
Natural log of absolute value of x from 1 to b. Sorry, no, from b to 1, sorry. No, like
Yeah, sorry.
Yeah, and then
and
this would be b approaching 0 from the positive.
B approach from 0 from
And like that would like you see what I'm trying to do, right? Like you're changing the
endpoint. Yeah, I mean I understand what you're trying to do.
And like that would result in 0. I think.
-1 to -B, that makes that. Yeah, but the issue with that is though that when you're saying -1 to -B, you're still plugging in.
They probably won't put something like this on the AP
I mean, they definitely 100% would not put something like this on the AP test.
Okay.
I'm just trying to think through how I feel about the -B and the 0 from the right. I still would say that because these limits that you've attached to the natural logs are different, that will disallow you from combining those two things together as just natural log of x over x. And so I still don't think that that's gonna, I mean, yeah, you can't combine those natural logs together because of the limits that you've attached to them, because those aren't the same. So those limits would have to be the same to be able to make just that, turn that just into natural log of x over x or natural log of 1. You see what I'm saying?
Wait, but there's an absolute value. So like if you were to expand those, limits, you would get natural log of the absolute value of -b, and since b is positive, you get the natural log of b. And then on the second natural log, you would get.
Well, you'd have natural log of b minus natural log of 1 plus natural log of 1 minus natural log of b. So you still end up. Yeah. Okay. All right. I guess I see what you're saying. Yeah.
And you'd still get 0.
If you expand them out, yeah, you would get 0. Yeah. There's an argument to be made for that, but yeah. I don't know. I'd have to think more about whether or not I would be able to say that that's 0 rather than being still divergent. But yeah, you make a good point. But yeah, you definitely won't see anything like that on the AP test. So yeah, wouldn't be too worried about it. Yeah, I'll think about that. Decide how I feel about that. Yeah, that's a good point. Let's do this one here. I think this is a good one. This one's got a little bit of series stuff in it. Just a little bit. It's also got just some basic stuff in it. Plus it's got some partial fraction decomposition stuff, improper integral stuff. Let's take a look at this one. I'll give you guys a few minutes to work through this. And then we'll talk about it. I know, Jenna, you've got to leave, right? In just a minute. I mean, you're supposed to be there at 11? You're good to go if you want. But I don't want you to be late for your AP test. So. Kevin, no, integrability does not imply continuity. The reverse is true. If something is continuous, then you should be able to integrate it. But the reverse is not true. You can integrate something across places where it's not continuous. You have 3 minutes left. All right, we ready to go through this one? Everybody at home ready?
Zoom good.
Zoom good. Okay. So for part A, what are we looking at here? We need to find the slope of the tangent line at x equals 3. So that should be pretty straightforward. Just take our derivative and evaluate it at 3. So this derivative should be the opposite of 3 times the derivative of that, which is 4x minus 7 over 2x squared minus 7x plus 5 squared. And that's at x equals 3. And so I don't know, whatever you get when you plug that in. What does that come out to be? Negative 15 over something. What is that? 18 negative 3. Did I do my arithmetic right there? 18 minus 27 negative 3. Yeah?
Yep.
We all feel good about that? Yeah? Okay. Everybody good with A? Yeah? Good. Part B. Find each critical point between 1 and 2.5 for f. So we've already got the derivative. So we set the derivative equal to 0. To figure out when it equals 0, we'd also set it equal to set the denominator equal to 0 to see when it's undefined, but we don't need to worry about that. because any value that makes the denominator of the derivative undefined will also make the denominator of our original function undefined, and you can't have a critical value in a place where your function is not defined. So all we really need to do is set 4x minus 7 equal to 0, which would be x equals 7/4. And then you have to classify that as a max, min, or neither. So you make yourself a sign chart and plug something in between 7/4 and 1 and something between 7/4 and 2.5 and find out that, I don't know, what does that come out to be? The denominator is always positive, so you plug in something like 2 into it, that's going to give you a negative. So decreasing, you plug in something like 1.1, that's going to come out to be a positive. So looks like it's a max. Everybody good there with part B? Any questions on B?
Wait, wasn't there something like you can't use a sign chart to justify a min or max?
I mean, you should state something to the effect of the derivative goes from positive to negative at 7/4, so it's a local max.
Okay, I see.
So
Thank
just
you.
make a classifying statement, just make a statement that says what your sign chart is.
Got it, got it.
I mean,
And
I've
we
seen them give points on like student work examples. I've seen them give points for just a sign chart, but just to be safe, write, half a sentence that says derivative goes from positive to negative at 7/4, local max.
And to clarify, don't list the values that make the denominator 0.
Yeah, those are not critical points, because a critical point can only occur if the function is defined, and if this denominator is equal to 0, then this denominator is also equal to 0, and therefore the function is not defined at that point, so it's not a critical value. Yep. So my guess is, I don't know, I didn't actually solve that, but my guess is, what is that? Does that factor? Yeah, factors to 2x minus 5 and x minus 1. Well, I guess that's your 1 and your 5 halves there that you're looking at on that interval. So you should, those wouldn't have been in the open interval 1 to 2.5 anyway. But even so, you still wouldn't include them because they make the original function undefined. Everybody good with that?
Yep, got it.
Cool. All right. So then we'll use this identity that they gave us. They did the partial fraction decomposition for us. We're going to evaluate the integral from 5 to infinity. 5 to infinity does not include any other discontinuities, right? Because this is 5 halves and this is 1. So we're going to integrate from 5 to infinity. And what was it? It was 2 over 2x minus 5 minus 1 over x minus 1. And so as we integrate this, this should be, well, first off, we'll write it as a limit as a approaches infinity of the integral from 5 to a of this, because we want to get our points. If you don't do that, you'll get 0 points. Then you'll integrate them both. So 2 over 2x minus 5, that's just u equals 2x minus 5. du is 2 dx, so that'll clear out that 2. And you'll just end up with the limit as a approaches infinity of the natural log of the absolute value of 2x minus 5 minus the natural log of the absolute value of x minus 1. From, what do we got? 5 to infinity. So 5 to a. Everybody good with that? And as we plug in our values, we end up with, what do we want to do with this inside of here? We'll rewrite this as the limit as a approaches infinity of the natural log of 2x minus 5 over x minus 1. And then we'll go from 5 to a on that, which will give us the limit as a approaches infinity of the natural log of 2a minus 5 over a minus 1 minus the natural log of, what do we get if we plug that in there? That gives us 5/4. Everybody good with that? Zoom, good or no? Zoom good or no?
Yeah, okay.
Good zoom.
Okay. All right. Good Zoom. All right. And then the 2a minus 5 over the a minus 1 as a goes towards infinity. The thing inside of here just becomes 2. So we end up with the natural log of 2 minus the natural log of 5/4, which would be 2 over 5/4, or the natural log of 8/5. Everybody good with that? Derek, you're good with that? Derek's the only one left in the classroom here with me now because Noah didn't show up and Jenna left for her AP test. So, people at home, are you good or no?
Good zoom.
Good Zoom. All right, and what was the last thing I asked? Oh, to determine whether this series converges or diverges, state the conditions of the test used for determining the convergence or the divergence. So, well, this is the same, this is a series that is represented by the function that we evaluated the improper integral from 5 to infinity, and this is a series going from 5 to infinity. So if our integral converged to some value, then what does that tell us about the series? Based on which test? This should converge using the integral test. I mean, we literally just did the integral, right? This is a positive decreasing value series with a positive decreasing continuous function. And so that'd be the easiest way to show this, right? That we know that based on the integral test, since these are both decreasing and they're both always positive, or in values greater than 5, right? If we're specifically looking at in values greater than 5. So if you went in values at 4, then it's not necessarily always positive, right? But in values at 5 and greater, they are. So you'd use the integral test. Everybody good with that? For some reason, my phone is not connecting to the internet, so I can't pull up the scoring guidelines for this one. So I can't tell you how many points this was worth. I tried like during that whole 15 minutes, but yeah. So I don't know how many points each part was worth. But any questions on the process there?
If you forgot that the integral test existed, and is it possible to use the direct comparison for this one?
Sure. Yeah, you could definitely do direct comparison with what did you do it with? Depends on what you did it with. But
Yeah, I used 1 over n squared, but I'm not sure if that's allowed.
yeah, so
Is that
direct comparison with 1 over n squared at n greater than 5. So you just have to check the values. My I don't know, like, so if you started at n equals 5 with 1 over n squared, you got 1 over 25. With 3 over 2n squared, what does that come out to be? 3 over 50 minus 35 is 15 plus 5 is 23 20ths. And we would need, we need that limit to, let's see here, we need the one that's on the top to increase less rapidly than the one that's on the bottom. And so we need to know, let's see, this one. Yeah, since 3/20ths, and then if you put in n equals 6, what's that going to come out to be? And these values are actually larger. Like 3/20ths, right, is more than 1/25th. So yeah, the direct comparison, I was gonna say the direct comparison test is a little bit of a struggle here because you have to have this one that, this 3 over 2n squared minus 7n plus 5. We need that one to always be smaller than our 1 over n squared, but it's not smaller than 1 over n squared. But you could go through and you could use the limit comparison test by looking for the limit as n approaches infinity of, what was it, 3 over 2n squared minus 7n plus 5 over 1 over n squared. So you could do limit comparison test. And then that becomes the limit as n approaches infinity of 3n squared over 2n squared minus 7n plus 5, which is 3 halves. And since 3 halves is less than infinity greater than 0, by the limit comparison test, they both converge or diverge, one or the other. And because 1 over n squared converges, then that tells us, by p-series, right, that tells us that this one also converges. But the direct comparison is not going to work. The limit comparison test would work. You would need to state also that these are positive, that these are positive series and a positive integral. But what they wanted you to do is note that it was really easy with the integral test, but using the limit comparison test is fine too. You just then need to note that 1 over n squared converges by the p-series test, and because both of these series are both positive or n at 5 or greater, that since this limit is between 0 and infinity, they both converge. Does that make sense?
Okay, gotcha. I'll probably just
Right.
use the integral test next time.
Yeah, the integral test would be a lot easier. But I mean, it's not a lot easier. It's a little easier. There's more writing to do for it, but either way is good. And my guess is probably in the scoring guidelines, if I keep trying to like refresh this, but it made them go away, and it's not letting me pull them up. I bet it would show both of those, but they would have wanted you to use the integral test. That's why they had you do part C. So. All right. Anybody else? Any other questions on that one? It's a good question. So Shri and Kevin, you're taking the test tomorrow. Everybody else is not taking the test tomorrow. Is that correct?